Okay, today we'll be talking about the kinetic model of matter. So in this particular chapter, we will first compare the different properties of a solid, liquid, and gas, and more important, and see how the individual structure at the molecular level is being will influence its respective properties. Find out and understand more on what is meant by bromine motion, and also to understand how the motion of molecules is in relation to the temperature. Okay, so for the state of matter, right, metals are usually made up of many different particles. So when we talk about particles, right, we actually learn things like atoms, molecules. So these are examples of states of matter or in regards of particle. But for physics, we tend to just represent a circle as a form of a particle. So in a state of matter, it can be made of many different particles or the same particles. Second thing, in room temperature, right, matter exists as solid, liquid, and gas. So these are the three states of matter that we have to be familiar with. And these three different states, there is two main ways that usually questions will ask. The arrangement and behavior, more or less is towards the movement. Okay, so in your answers, right, do be able to write in a way to structure your answer, you have to relate what is an arrangement and what's a movement. So in other words, right, this is a key table for as a summary that it will be good for to be used for memorizing, where the motion in the solid state is very different from how it is from the liquid to the gas state. So for the solid state, the motion would tend to actually vibrate only at about their fixed position. And in this case, right, it is wrong to say that it is stationary, or from the picture we see that it's actually one. No, they are stacked against each other. So when we talk about vibrating about its fixed position, right, it means that this particle will stay at its position, but at the same time, what it do is it will actually move and vibrate. So this is generally what they meant by vibrating about its fixed position. Okay. Next is the forces of attraction, as they are actually arranged very closely together as well as in a fixed regular position, right? What will happen is the interaction force between the particles, they tend to be very strong. And having even stronger forces of attraction together, right, will make it, right, actually limited in terms of its movement, right, moving from a very, let's say, this position over here, far position, to somewhere move everywhere around the solid. It will just stay at its position and vibrate only. Okay. Whereas if you look at the liquid, right, the liquid is a bit more fluid in terms of what aspects. Number one, in terms of motion, they tend to slide past each other quite easily. Okay. And in this case, right, because of its sliding, meaning it can move left, right, up, down, and what's not, the force of attraction still exists, but they are in a more moderate amount. Lastly, because of the force of attraction is also very not that strong, the grab between them is actually weaker. Hence, they can actually move around more randomly and freely. I wouldn't say freely, I would say more randomly, and it will actually establish an irregular structure. The distance, however, is still relatively close together, where you can see some of the particles the molecules or particles are actually touching against each other. Finally, we look at gas. For the gas, right, the motion, they are always moving freely in all directions at very, very high speed. And why is it so? It's because of force of attraction, the force of attraction between the particles are so weak that they are not holding each other. So they can move everywhere very freely and randomly. Arrangement wise is irregular, as well as the particles are very far apart from each other. So you may want to take some time to actually remember this table, because it's also related to your chemistry topic. Most probably it's the first chapter, second chapter on kinetic particle theory. Okay, next we look into the properties of solid, liquid, and gas. Now, these properties, right, are very is similar to what we have studied in primary school, where the solid has definite shape and definite volume. The meaning of definite means there is no change. That means it doesn't change its shape Some textbooks, they may put it as fixed shape or fixed volume. Okay, but use the words definite will be better. Then, of course, liquid, the shape is actually indefinite, or we can say not definite. Reason being is because of the forces of attraction available, right? It always form bonds and break bonds and things like this. The liquid is the particles are free to move and slide past at those empty positions, hence taking the shape of containers. The volume, on the other hand, doesn't change much, therefore the liquid is actually having a definite volume. For the gas, both of it is indefinite. Later we will be talking about how or why are they in this kind of thing. And lastly, compressibility. Do know that for solid and liquid in your syllabus, they are not able to be compressed. While we also do know for the liquid, sometimes if you use sufficient force, you can squeeze a little bit, but in exam, right, usually we consider these two as non-compressible. Whereas on gas, right, because of the empty spaces, the particles with enough pressure or force to it, the particles can move into these free spaces, and hence they will be able to compress. So in terms of properties for solid, liquid, and having fixed volume as compared to gas, is because of the motion of the particles. When a solid and liquid, they are generally helped by the forces of attraction, and also they are not free to move in all directions freely as compared to the gas. Hence, the volume is actually fixed. Gas, on the other hand, is because of the force of attraction is weaker, therefore it is more able to move freely and randomly in all directions, hence having indefinite volume. Solids will have fixed shapes as compared to your liquid and gas. Again, it's because of the arrangement of the particles. So this is where, because your solid particles, they are already arranged side by side towards each other, they are regularly arranged and are fixed in this pattern. Hence, without any space, the other particles to move into, the shape is fixed. However, if you look at liquid and gas, there's still space in between. With the correct amount of force or pressure, these particles can replace such empty space and hence result in a change in the shape of the state of matter. Solids will have a higher melting and boiling point, and this will actually bring all the way down to gas, because your forces of attraction between particles are the highest for solid and the weakest in gas. So for force of attraction, usually for melting and boiling point, it really depends on the amount of heat energy required to overcome these forces of attraction, leading to the identity of, or the variation of where the different the melting and boiling points will be at. Then, of course, with regards to diffusion is basically the net movement of molecule from the region of high to low concentration of the particle. What we can see is the rate is generally faster in gas than liquid or solid. Reason being is because, again, the speed of how the particles are moving. When the gas, they are moving freely at very fast speed, and in this case, for solid, they tend to only vibrate about their fixed position. For liquid, they're only able to slide past one another. Finally, compressibility, or gas can be compressed easily as the distance between the gas particles are wide and far apart. They will have more space to be compressed, and hence the particles in the solid and liquids are close together and are not easily compressed as they have little space between them. Now comes Bromine motion. So Bromine motion, right? So one guiding theory is that all metals are either made up of atoms or molecules, and they are always in a state of constant random movement. So for what is meant by Bromine motion is this random movement of microscopic particles suspended in a liquid in a fluid, either in a gas state or liquid state. And these are usually caused by collisions with molecules of the surrounding. So let's say we are looking at the dust particles floating around. It is actually, why is it moving randomly? It's because sometimes it's also colliding with the existing air particles that you can't see. For example, your oxygen, your carbon dioxide, your hydrogen gas. So these are the ones. So in order to show Bromine motion, we actually use smoke particle as an experiment, where the microscopic particles in air, like your dust particles, are always moving randomly in a zigzag manner. And in air, it also contains your other molecules that you are not visible, like just now what I shared, like your oxygen, your carbon dioxide. However, they have size and mass. So these atoms and molecules together will always move randomly, and due to that, there's a chance or a frequency of them actually colliding with each other. So this constant and uneven or random collision will then result in the smoke particles to actually move in a jerky or zigzag manner. So in exam, sometimes they may ask you to actually draw or to highlight what is the direction of these particles. Now comes to the effect of temperature on the motion of molecules. So in kinetic theory, all metals consist of particles are always in motion. According to the kinetic particle theory, temperature that led to a measure of the average kinetic energy thus influences the movement. So either an increase in kinetic energy may show an increase in temperature, leading to an increase in the movement of the particles. When heat is supplied to the air molecules, this large heat is converted to kinetic energy. For their movement, they move faster, hence average kinetic energy will increase. So in the observation of the bromine motion of the smoke particles, we can see that they are actually moving a lot faster when you increase the temperature of the environment. And this is because not just the smoke particles, but also the air particles are moving faster, and this promotes frequent collision, leading to bombardment and more frequent movement of the dust particles. Next, we look into the pressure in gas and how pressure would actually relate to the motion. So for molecules of a gas, and this can only happen usually for gas, right? Why? Because it is compressible, but more importantly, of it being flexible and allowing some form of pressure to be put into. So due to the random motion, they tend to collide with each other, especially with the walls of the container is constantly. So in this case, right, when the gas particles they hit the inner wall of the container, this will actually exert a force, leading to pressure. And the average force exerted by this gas molecule over the particular area of the container, in this case, which is the sites here, like what I highlighted, okay, is pressure, and this is due to the total sum of all the collision forces. Now, this comes in either an MCQ or early structure question in terms of how are we able to plot a graph between pressure and temperature. So when the mass and volume of a gas it remains constant, this has to be one key assumption for the change in pressure to be directly proportional to the change in temperature. Meaning, if we look at the temperature as the x-axis, the pressure as the y-axis, any further increase in temperature will cause an increase in pressure. So this is something similar to our pressure cooker. Okay, and the reason for this is because as the temperature increase, the average kinetic energy of the particles would also increase. This average kinetic energy of the particles increase will lead to the particles to actually move faster, and in other words, hit the walls of the container faster. When they hit more onto the frequency of it colliding with the walls of the container faster, we will see that there is actually a greater buildup of force, leading to a greater buildup of pressure. Okay, so generally, this is the whole idea behind this linear line graph. On the other hand, what about volume? So for volume-wise, right, when the mass and pressure of the gas remains constant, this change in volume is usually directly proportional to the change in temperature. Meaning, if let's say I change the the y-axis as volume rather than pressure, we would see that there is still a linear increment. Now, why is it so? Because the average kinetic energy is proportional to the temperature of the gas. This is where temperature increase, kinetic energy increase, leading to collision of the water container more frequently. This will exert greater force, hence greater pressure of the container. Okay, and if the walls of the containers are flexible, this will expand until the pressure inside of the container balance the atmospheric pressure outside the container. Therefore, volume of gas would increase when the temperature of the gas increase. So think of it more of like something like expansion in a way of influencing the volume. Then if I were to readjust it to pressure and volume, how will it be? There is this inverse relationship. Inverse relationship means rather than things going up, when you increase the amount of the variable, it will actually decrease. So in this case, when gases can be compressed easily, there are more space in between these particles. And hence, when the particles take shorter time to hit the wall, volume will be greatly reduced due to the reduction in volume. There will be a greater reduction in this collision, hence lesser pressure. Therefore, in a nutshell, as the pressure of a gas increase, the volume of the gas will decrease. So pressure increase, volume will decrease. So that is all for this particular segment. I hope I have answered some of your questions. Stay tuned. Thank you.